Similar to how we can uniquely identify an individual with his fingerprints, hash functions can be used to identify a file or a string or any data uniquely we can identify with the help of hash functions. Let's see how and what are the typical use cases of hash functions. So what is a hash function or what is hashing? Hashing is essentially a way to compress data into unique fingerprint. So we have a plain text and what we get after hashing is a hash text. And what are the properties of this hash text? The hash function outputs a fixed length. So the first property is that this is a fixed length string of characters called a hash value, hash code, or hash digest. So if you read the words hash value or hash code or hash digest or only digest, they all mean the same. So that is the output of the hash function, which is called all these names. The value is significantly shorter than the original data. So let's read the definition one more time. Hashing is essentially a way to compress data into a unique fingerprint. So we are compressing the data which is sent to a unique and fixed length fingerprint. Now for understanding purpose, what is a function? So let me give you an example of a function. A function can be a square. So if you are doing a square of 5, then what you get is 25. Now with this 25, if you know the function is a square, then you are able to find out, if you take a square root of this, you know the original number is 5. So with this kind of function, what is happening is that whenever you want to decode it back, you want to get into the initial form, you can get. So from the output of the application of the function, it is still possible to get to the input which was provided to the function. From 25, which was the output, we are still able to derive that the initial value was 5. Now in hash functions, what happens is it's a one-way function. So whatever the hash digest you have got, you would not be able to get into the plain text, the original text. You would not be able to reverse engineer and you would not be able to go back from the hash text to the plain text. That is one very key property of hashing. So you have an input, you use a cryptographic hash function here, and this is the digest you get. Let's quickly see how can we get the digest, the output of the hash function, using these tools in a Linux or a Mac machine. So I'm going to echo Fox and I would use a SHA-1 algorithm here. This is a pipe, that means output of the echo is going to go to SHA-SUM. And if you see this is the same output which we have got 2D17 CA99, and you can leverage the Open SSL also for the same purpose. So if we have to use Open SSL, we have to do the same thing. We have to pipe the Fox, and where we have to pipe it into Open SSL, and we have to say that we are intending to use SHA-1. So you will get the same output with this also. So you can use either of them. If you have to use MD5, you can pipe the text into MD5. Same thing can be done for files also. So we are able to generate the SHA-1 digest very easily with the help of command line in Mac machine. The same can be done in Linux and Windows as well. So these are some of the popular algorithms for the hashing: MD5, SHA-1, SHA-256, SHA-3, bcrypt. And what is recommended is SHA-256 and SHA-3 are among the more widely and recommended hash functions. Why they are more recommended is because the other one have been found to have some vulnerabilities. Now let's recap some of the key points which we had discussed earlier. Hashing is one way, we discussed it earlier. Collision resistance. Hashing aims for having collision resistance. What is a collision? So you provide an input and after hashing you get an output. So for two different inputs, if the output is same, that is called as a collision. Ideally what would happen is that whenever the input changes, even a small bit of information on the change of input would result in a different output. But there are cases, very infrequent, but there can be cases where then this collision can happen, where a very different input could lead to the same output. That is what is collision resistance. Let's read it. Ideally, different inputs should produce unique hash values. This is called collision resistance. A good hash function minimizes the chance of two different pieces of data having the same hash value. So that's what hashing aims for. Data integrity. Hashes are often used to verify data integrity, and how, we are going to see it in a bit. These are the three prominent use cases of hashing. Password storage, how we store the password. Data verification, how to verify that the data which has been sent to us is correctly received by us. It is not manipulated in the network, or it has not been errored out in the network. How can we verify that? That is done with the help of hashing. And digital signatures are very wide and common, wherein you verify the signee of a document by the digital signatures. What is digital signature and how this is implemented is what we are going to see further. So data validation. When you download any file from your server, somewhere from the internet, from the server, you want to verify whether during the transmission, when it came from network to you, whether the file is still having the same content as was intended to be sent. So that's where this hash is very important. So what we do is, when we are transmitting a file, we send another payload along with it, which is the hash of the message which we are sending. So this file, we will send the hash as well. And when it is received at the destination, from source it travels. Let's say this is the source. From source to destination it travels, and at the source you calculate the hash, along with the file you send the hash, and at the destination you receive the message and you receive the hash, and then you take a hash again of the message. If it is matching, the hash is matching what hash had come from here, then this is a valid message. There is no integrity issues with the message. But if the hash of the message is not matching the hash which was sent, then there is a problem. Software updates, similar thing is done for software updates also. When the package is downloaded, they come with the hash values. This is to maintain the integrity of the file and ensures that you are leveraging the correct download package. Verifying the hash ensures you are downloading the intended update from a trusted source and not from a tempered version. Data storage. Again, let's say this is some kind of application which you have written. There are users, there is a traditional server. Finally, you store the data to a persistent disk. So when you are storing the data in a persistent disk for backup, let's say for a long time archive, you are going to Amazon Glacier or something. For a short term, you have a local store, and then you leverage S3 also. You want to ensure that the files which are getting stored are correct. And how you can verify? You can verify by comparing the hash of the file at the source and at the destination, and thereby validate the data. The other important use case of the hashing is digital signature. What is the aim of digital signature? So authenticity, that signer is confirmed as the signer. Integrity. Integrity means the message which was sent to you is the same. It is not being tampered with. It is the same when it was sent. The message is not changed during the transmission. That is the integrity. Non-repudiation means that the person who sent the message cannot deny later that I have sent this message. So prove to all parties the origin of the signed content. Repudiation refers to the act of signer denying. So when we say non-repudiation, the signer cannot deny that I have not sent this message. So how do we create a digital signature? So when we have to send a document from the source to the destination, what we do is, in the document, along with the document, what we do is we calculate the hash of this document, and that hash also is sent along with the document as a signature. So what we do is, first thing is, we will be calculating the hash of the document, and then this hash text would be encrypted with the help of the private key of the sender. So if you know the PKI infrastructure, PKI public key infrastructure, you know that there is a public and a private key, and whatever is encrypted with the private key can be decrypted with public, and vice versa. So, and the public key is available to everybody. So this private key is available only to the sender. Thereby the sender cannot say that I have not sent this message. He cannot do a non-repudiation. Why? Because the key is available only with the sender. So this hash text is encrypted, and this encrypted text is sent with the file. Now once the receiver has received this file, they have to validate whether this is the correct file, and the validation is done with the digital signature, that who has sent the file, that verification and validation is done with a digital signature. So this content was received by the receiver here. So what he will do is, receiver will again calculate the hash of this. So this hash is what is calculated here. And what is the other thing which will be done? The receiver will take this message, and with the public key he will decrypt. So once he decrypts it with the public key, he will get the original hash. So this hash is same as this hash. So he gets the original hash, and here the hash was again calculated using the same algorithm. If it was SHA-256, using the same SHA-256, the hash was calculated again. And if these messages, these digest match, what does it indicate? It indicates that the sender has sent this message. Okay, and there is no tampering of the message on the transmission. So the third important thing which we want to discuss is the password. So whenever you store your password in the database, what is being done is the passwords are not stored as the plain ASCII characters. Why? Because let's say the database is compromised. Somebody is having the access to the database and they don't have a good intention. They can read all the passwords and they can disclose them. So passwords are never stored in the ASCII format. They are always kept as a hash. Now storing it in a hash format means that the person, even if he reads the hash, he or she cannot arrive at the original password from the hash. Why it is not possible? Because of the way the algorithm of the hashing is designed. So original text cannot be, it's a one-way movement. So original cannot be decided, or original cannot be deciphered from the hash which you find in the database. So what we do is, so we always store the hash of the password in the database. Another thing which is done is usage of something called as a salt. So there is an attack which is called as a rainbow attack. So in rainbow attack, what happens is that, let's say we have a list of passwords and their associated password and their associated hash functions. So what we can do is we can compare. Let's say I have the access to the database and I have malintentions. I can again compare with my list of hashes which are available to me, pre-calculated hashes, and if some match comes, I would be able to get the original password, because this hash is matching. So this hash is coming from this password. So I would be able to know that my password or this user's password was this. So that's where this is called as a rainbow table, where you have the password and hashes available, and against which you compare the hashes and derive the original password. So to avoid this problem, what we do is we introduce something called as a salt. So salt is added to your password, and it would be a random character, this salt, and then this hash which is calculated from password plus salt is something which is stored as a password. Okay, and this salt is also stored in your database, and thereby what we achieve is we achieve much more secure password storage system. And this salt, important thing to remember is this salt is always changed when you are changing the password. It's a randomly generated text, and it is different for all the users which are there in the database. All the unique users, the salt is different, and thereby it is virtually very difficult and impossible without leveraging lot of computing resources to arrive at the password. Because again, reverse tracking would be so difficult, because every individual user has his or her own salt, and it is being hashed, and it is the algorithm itself is not reverse engineer possible. The only thing which can be done is this kind of rainbow table which can be created, and with so many permutations, the rainbow table creation would be almost impossible. So thereby this salt is a very important concept, and it must be used when you are storing passwords in your database. So these are the three important use cases for the hash functions. I'll close it here. Thank you very much.